Hi folks, we're going to take a look at the solution to 5b from page 408, and it's a question on solving an exponential equation. And this is the type of exponential equation that's solved a little differently than most of the others. Okay, and the reason why it has to be solved differently is that you can't easily write both of these exponential expressions using the same power. Okay, so the way we do this is to exploit the ski-slope rule. So what we do is we take the logarithm of both sides and then bring down the exponent using the ski-slope rule. And you can use the logarithm to any base. Now in general, we tend to use log base 10. Okay, and the reason why we do that is that if we wanted to get an approximation for our answer, well then it'll already be in terms of log base 10, and so we can use our calculator. Okay, because the ski-slope rule works with any base. So once I take the log of both sides, I can now bring down the exponents. Now be careful here when you're bringing down this k minus 2, because it's that whole number that's being multiplied to log 2. Okay, so in other words, we need brackets around that. Okay, same thing here, brackets around the k plus 1, and then times log 3. Now I want you to look at this equation, and I'd like you to realize that this is just a linear equation. Okay, because here we've got our variable has a power of 1, and this log 2, log 3, they're just numbers. Okay, so I'm going to solve this exactly the way I solve any linear equation. So first step is to expand and simplify both sides of the equation. So I'm going to distribute the log 2 to both of those. Okay, so I've got log 2 times k. I just put a brackets around log 2 to make it a little clearer. Okay, and then minus 2 times log 2. Okay, now because I'm looking for an exact answer, I'm not going to approximate log 2. Okay, do the same thing here, distribute the log 3. So I've got log 3 times k plus log 3. Okay, so just to keep in mind, this log 2 is just the coefficient of that variable. Log 3 is the coefficient of that variable, k, and these are just constant numbers. Okay, so now I follow my usual process. I bring all the variable terms to one side, all the constant terms to the other side. Okay, so here we've got log 2k minus log 3k. Okay, and then here we've got log 3 plus 2, log 3 to log 2. Okay, now again, here these are just like terms. How does one subtract like terms? By subtracting the coefficients. So this just becomes log 2 minus log 3 times k equals log 3 plus 2 log 2. Okay, and now I can solve for k. So I just divide out this coefficient to both sides. So I'm left with log 3 plus 2 log 2 over log 2 minus log 3. Okay, and this would be your final answer. Okay, now you can simplify this a little more. Okay, so I will do that just to say that we've done it. The other thing you can do is notice that depending on which side I brought my terms, okay, I might have things in opposite order in the final answer. So I don't know what how the textbook has given their answer, but they just might have things in opposite order depending on how they solved it. Okay, so here when I talk about simplifying more, you could bring this 2 up and then use your logarithm rules to bring these together. Okay, so I suppose you could write this as log 3 plus log of, bring that 2 up, so it becomes log 4, 2 squared, over log 2 minus log 3. Okay, and you could simplify a little more, because here log 3 plus log 4, you could use the addition rule to write that as log 12, and then here this you use the subtraction rule, so this would become log of 2 over 3. Okay, but I would say either of these answers are perfectly reasonable. Okay, so just to recap, okay, this is a bit of an exception to the rule, because normally we try to write all the exponential terms using the same power. In this case here, that's not easily done. So the trick is to take log base 10 of both sides, use the ski-slope rule, and then solve it. As in this case here, it's a linear equation. If one of these k's had been squared, it would have been a quadratic equation.